Okay, section 2, we're going to look at some techniques for evaluating limits, the dividing out and rationalizing technique, how to approximate limits graphically and numerically, one-sided limits, and limits of the different quotients, which is a calculus-based idea. Okay, so let's move on. All right, we want to find the limit of the function x squared plus x minus 6 divided by x plus 3 as x approaches negative 3. Okay? So if we think of it as a rational function and we substitute in the negative 3, we'll notice that we get this 0 over 0. Okay? Dividing by 0 is undefined, or what we also call this sometimes is we call it an indeterminate form. Okay? So we can't, that's not going to work. And if we look at the graph of the function, we want to see, does it appear that the limit doesn't exist in the graph? Or does it look like there is a limit according to the graph of the function? So let's make an input-output table for our function. And when x is negative 2, we'll find that y is negative 4. At negative 1, we're at negative 3. 0 puts us at negative 1. And, 0 puts us at negative 2. My mistake. And at 1, we're at negative 1. So if we look at plotting those points, negative 2, negative 4 is down here. Negative 1, negative 3. 0, negative 2. And we notice, what is this graph starting to look like? Well, it's starting to look like a linear function, a line. Okay? But if we look at the function itself, what happens when we put in negative 3 for x? Okay? If we put in negative 3, we get an undefined. So when x is negative 3, we're actually going to have a hole in our graph at x equals negative 3. Okay? But if we look at the limit, okay, as we are approaching from the right or as we are approaching from the left, in either case we seem to be getting closer and closer to an actual value. This doesn't resemble a function that has no limit. Okay? So how do we actual limit algebraically? Well, what we want to do is we want to divide out the common factor before we start evaluating the limit. If we look at x squared plus x minus 6, we could factor that to x plus 3 and x minus 2. So what happens now is that the x plus 3's are going to divide out. And what I'm left with is the limit as x approaches negative 3 of x minus 2. So now, if I put in negative 3 minus 2, I get negative 5. Okay? So the limit of this function here, the x squared plus x minus 6 plus 3, is actually equal to negative 5. Okay? Next example. Okay. X minus 1 over x cubed minus x squared plus x minus 1. Okay? So we have to be able to factor that denominator. Well, if we look at the denominator, I could factor out an x squared and kind of do a little factor by grouping to where this becomes x minus 1 divided by x squared plus 1 times x minus 1. So now that the x minus 1's will divide out, then I'm actually looking at the limit as x approaches 1 of 1 over x squared plus 1, which is 1 over 1 plus 1, which gives me 1/2. Okay? If I were to evaluate back at the beginning for the 1, I would end up with that indeterminate form again. I would end up with a 0 over 0. So we have to make sure that we simplify and divide out those common factors before we try Evaluate the limits. Okay, so try this one. Well, the x minus 6 stays the same, but x squared minus 36 is x plus 6 times x minus 6, which means we actually end up with the limit as x approaches 6 of 1 divided by x plus 6, which is 1 over 6 plus 6, which gives me 1/12. Okay, so the limit of x minus 6 divided by x squared minus 36 as x approaches 6 is actually equal to 1/12. Okay. Now another technique is called rationalizing. Now we've rationalized before when we had radicals in the denominator, but there are times when we're evaluating limits that we need to rationalize the numerator, because as my x is approaching 0, okay, you can see that I don't want to end up with a 0 in the denominator. So remember, to rationalize radical expressions, we're using the conjugate. So I'm going to multiply by square root of x plus 1 divided by square root of x plus 1 plus 1. Okay? So I'll actually have the limit as x approaches 0. And remember, this is an a minus b, a plus b scenario. So that gives me a squared, which would be x plus 1, minus b squared, which is 1, divided by x square root of x plus 1 plus x. Okay? So we really have x divided by, I can factor out an x, and that gives me square root of x plus 1 plus 1. Those x will simplify. Okay? Leaving me 1 divided by square root of x plus 1 plus 1. And when I evaluate that as x approaches 0, I'm going to have the square root of 1 plus 1, which is 1/2. Okay? Simply by substituting 0 in for x, being that is a rational function. Okay? And last one. So we need to, again, rationalize. So we are going to multiply by square root of 5 plus x plus square root of 5 divided by square root of 5 plus x plus square root of 5. So we will have the limit as x approaches 0 of 5 plus x, oops, not 5 plus 5, 5 plus x minus 5 divided by x times the square root of 5 plus x plus square root of 5. Well, our 5's up here are going to go away, and then I'll be able to divide out the x term as well. That x and that x will divide out once the 5's are gone, and I will be left with 1 over square root of 5 plus x plus square root of 5. So if x is 0, I'm going to have 1 divided by 2 times the square root of 5. Okay? And I could leave that, but if I were to rationalize the denominator now, then I'd have the square root of 5 divided by, that square root of 5 is 5 times 2, which is 10. So the limit would be square root of 5 divided by 10. Okay? So hopefully those made a little bit of sense, and we will get some more practice over those in class tomorrow. See you then.